Alright guys, so let's talk about redox reactions. First off, you need to know what a redox reaction actually is. A redox reaction is where one participant moves electrons from an area of high energy to low energy. And it does this to achieve a stable outer shell. So if we go to our pen down here, what that actually means is that when you do it, you release energy, okay? So therefore, delta H would be negative. Now, it has two parts. It has a reduction and an oxidation, okay? So these are two, this is where we can split the equation, the reaction into half, where one half loses electrons and the other half, the oxidation half, gains electrons. So over here is essentially where we have atoms that are likely to lose electrons, and here we have atoms which are likely to gain electrons. Now, we need to know what the oxidation state is. The oxidation state, or the oxidation number, which is the theoretical number of electrons that an atom has lost or gained. And if an atom loses electrons, it has a positive number, because it has given an electron to the system. So it's +1, it's given one. Now, oxidation states, they help us keep track of where the electrons are at. And that's really important. So they help us keep track of where the electrons are moving to. And this allows us to essentially break it in half and then put it all back together. So I need you to focus on this equation right here. This sentence up the top here. Oil rig. Oxidation is loss. Reduction is gain. Write this somewhere big. You're going to keep coming back to this all the time that you're doing this, okay? You'll need to go back to first principles to check that. So essentially, down here we have the oxidation states written above. We'll show you in the next slide how to get to those. First off, hydrogen has oxidation state of 0. And over here, the hydrogen has an oxidation state of +1. Now, actually, that should be a -1 there. Okay, so it's +1. But see, it has the 2 at the front. That means it's actually +2 because it's given 2 electrons. Over here, the chlorine, on the other hand, is 0. Starts at 0. That's an element. Goes over here and is now -1. What is actually happening is that the electron here is going over to the chlorine. Okay, so it's -1 because it's taken an electron in. So if oxidation is lost, that means the hydrogen is oxidized. Okay, so we got the H2, the element, which goes to H+, because remember, this over here is an ion, so that's an ionic compound. And these are elements. Okay, so it's gone, it's given 2 electrons away. Then we have the reduction. Reduction is gain. So here's the chlorine, and it's taken on these 2 electrons, which come from there, and you've now got Cl-. Okay, so oxidation is loss, reduction is gain. We then combine these 2 equations together to give us the total equation here. So these are the ionic half equations. So let's have a quick look at how we work out the numbers, or the states, the oxidation states. If it's a free element, it's 0. For an ion, it's the charge. Oxygen, which I obviously can't spell, oxygen is -2, unless it's a peroxide, then it's -1. When we get to hydrogen, it's +1 with the non-metal, -1 with metals. Remember, it's the same as the ionic charge of it. Neutral compounds, the sum of the ionic charges equals, or the oxidation states, is 0. Okay, so over here, this is a neutral compound, so what we're going for is 0. Over here, we're going for a total oxidation state of -2. Okay, so we'll come back to those in a minute. But first, let's have a look at water. All right, so water that's with a non-metal, so it's +1, and oxygen is always -2. Now, they don't add up. That's a -1, except, look at that, which means we multiply it by 2. So it's actually +2, -2. Cool. Over here, this is an ionic compound, so it's the same as the charges. Here we have a +1, because it's in the first period, and here we have a -1, because it's in the period 7. Now, this is where it gets a bit tricky, because of this crazy sulfur. Now, you don't have a rule for sulfur on there, so Don't stress. We'll come to it. You'll see what happens. All right, zone it, because this here makes a free radical of -2. Okay, all right, an ion. So over here, we've got this is a +1, except it's +2 because of that little number there. Over here, the oxygen, now oxygen is always -2, so it's -2. And over here, it goes to -6. So if you put those together, it's -6 plus 2 gives you -4, which means this sulfur must be +4. And over here, now, just to make it really tricky, if we go over here, okay, so oxygen, always -2, all right? Now, there's 4 of them, which actually makes it -8. Now, the magic number for us to get to is not 0 in this case, it is -2. So we've got sulfur here. Now, to get to -2, we need 6, and that simply means that sulfur has a valency, not a valency, an oxidation state of +6. So sulfur in this case gives 6 electrons, okay, to the whole equation. All right, so that's that. Now, let's have a quick look here. This is our equation we've looked at a few times now for our displacement of metals. So it's the zinc being oxidized because it's losing, and the copper being reduced because it's gaining electrons. So if we go over here, we'll write up the oxidation states as we go. Okay, so this is 0 because it's a free element, and it goes to +2 because it's the same as the charge. Here it is +2 because it's the same as the charge, and it goes to 0 as a free element. So let's have a look. So zinc loses electrons. Okay, copper gains electrons. Over here, zinc is oxidized. This is where we're about to get tricky. Zinc is oxidized, copper is reduced. Over here, zinc is the reducing agent. What that means is that the zinc causes the copper to reduce. It is the reductant. That's what we call that. So zinc is the reductant. Copper, which is reduced, causes the zinc to be oxidized. So it's the oxidizing agent. It also means it is the oxidant. So if you've got too much copper hanging over your zinc, it's an oxidant waiting to happen. And over here, we can see that zinc increases its oxidation state. So when something is being oxidized, its oxidation state increases. Copper is being reduced, which means its oxidation state decreases. And that's it. See you in class.